I think it's an absolutely genius idea. What am I talking about? Well, using small asteroids not just as sources for mining operations, but actually transforming them into real spaceships. Small worlds that can navigate everywhere, carrying colonists, materials, and infrastructure with them. Don't believe it? Keep watching. Ever since humanity started dreaming about conquering space, the idea of exploiting asteroid resources has always been part of our collective imagination. For decades, scientists have imagined robotic missions that would reach these celestial bodies, extract precious minerals, and bring them back to Earth. We talked about small mining bases, robots digging tunnels, orbital refineries processing raw materials. The approach was always the same. Go there, take what you need, come back. Like the Klondike Gold Rush, but in space. And to transport all this treasure, we imagined space cargo ships getting bigger and bigger, more and more expensive, more and more complex. Titanic spaceships that would shuttle between asteroids and Earth, burning monstrous amounts of fuel to move their precious cargo through the cosmic void. But in recent years, while everyone was looking in that direction, a group of engineers and scientists started thinking about something completely different. What if, instead of bringing the asteroid to us, or going to the asteroid with enormous spaceships, someone wondered, we transform the asteroid itself into a spaceship? I'm not talking about towing it or pushing it like some cosmic trailer, but something much more radical. Take an asteroid, install engines on it, and transform it into a habitable space vehicle where entire communities can live while traveling through the solar system. The idea is so simple it seems absurd, yet it's genius precisely in its simplicity. Think about a medium-sized asteroid, say half a kilometer, about 1,600 feet in diameter. It's a flying mountain with enough mass to provide natural protection from cosmic radiation, enough material to build habitats for thousands of people, enough resources to sustain a self-sufficient community for centuries. Now add engines, not traditional chemical rockets that burn tons of fuel in minutes, but long-term propulsion systems that can gently push this mountain for years, decades, using part of the asteroid's own mass as propellant. The concept completely flips the space exploration paradigm. Instead of building bigger and bigger spaceships to protect astronauts from radiation, you use the asteroid's mass itself as a shield. Instead of bringing all the food, water, and air from Earth, you extract these elements directly from the asteroid. Many C-type asteroids, the carbonaceous ones, contain up to 20% water in the form of ice. Water isn't just something to drink. It's oxygen to breathe, hydrogen for fuel, a medium to grow plants in hydroponic greenhouses. It's life, literally. The technology to do all this isn't futuristic science fiction. Ion thrusters, for example, already exist and have been successfully used in several space missions. These engines accelerate ions, electrically charged atoms, to incredible speeds, creating a small but constant thrust. A single ion engine's thrust is tiny, equivalent to the weight of a sheet of paper on your hand. But in space, where there's no friction, this microscopic thrust accumulates day after day, month after month, until it reaches speeds that chemical rockets can only dream of. And the beautiful thing is you can use almost anything as propellant: xenon, argon, or even vaporized material from the asteroid itself. Imagine carving tunnels and caverns inside the asteroid. You don't have to worry about pressurization like you would with a thin spacecraft wall. You have meters and meters, yards and yards of solid rock between you and the vacuum. You can create enormous environments, actual underground cathedrals lit artificially, where people can live, work, even grow food. And while the asteroid travels slowly but inexorably towards its destination, this community can grow, evolve, become something more than just a mining outpost. The economic difference is staggering. Building a spaceship capable of safely transporting, say, 1,000 people through the solar system would require an immense structure with redundant life support systems, incredibly heavy radiation shields, food and water supplies for years. We're talking thousands of tons of material that must be launched from Earth at a cost of about $20,000 per kilogram or $9,000 per pound. Do the math and you'll want to cry. But an asteroid, it's already out there. You don't have to launch it. You don't have to build it. You just have to modify it. And here's where another fascinating technology comes into play: solar sails. Instead of using only engines that consume propellant, you could deploy enormous reflective sails that capture the pressure of sunlight. Yes, light has physical pressure, even if infinitesimal. But with sails spanning square kilometers or square miles, which could be built using materials extracted from the asteroid itself, this pressure becomes a significant propulsive force. And the beauty is it's free. As long as the sun shines, you have thrust. You could combine solar sails for initial acceleration and ion engines for fine maneuvers and arrival at destination. But let's go beyond simple propulsion. Think about the social and psychological implications. Astronauts on traditional missions suffer from claustrophobia, isolation, physical deterioration due to microgravity. On an asteroid transformed into a spaceship, you have space. Lots of space. You can create rotating centrifuges for artificial gravity, underground parks with real trees. Yes, trees growing under LED lights powered by solar panels. Artificial lakes for swimming and fishing. It's no longer a survival mission in a high-tech sardine can. It's a community living on a small, mobile world. And let's talk versatility. An asteroid spaceship doesn't necessarily need a fixed destination. It could become a cycler, a sort of cosmic ferry that perpetually orbits between Earth and Mars, or between Mars and the asteroid belt. Buzz Aldrin, the second man on the moon, proposed exactly this concept, putting large habitats on orbits that naturally bring them close to different celestial bodies in sequence. Once the orbit is established, you barely need any fuel. It's like a bus that stops at the station every few years. You get on when it passes near Earth, you get off when it arrives near Mars. The beauty of this approach is that it scales naturally. You start with a small asteroid, maybe 100 meters or 330 feet in diameter as proof of concept. You put a small crew of pioneers on it, a dozen people at most. They start digging, building, expanding the habitat while the asteroid travels. As the infrastructure grows, you can welcome more people. After a few decades, what started as a Spartan outpost could have become a space town with hundreds or thousands of inhabitants. And let's not forget the mining aspect, which remains fundamental. While living on the asteroid, you can continue extracting and refining its materials. Iron and nickel for structures, platinum and gold for electronics, rare earths for advanced technology. But instead of having to ship everything to Earth at prohibitive costs, you can use these materials to expand the habitat, build new sections, manufacture tools and machinery. It's a circular economy in space. The asteroid provides resources for its own transformation and for sustaining its inhabitants. Now let's talk concrete numbers to really understand what we're dealing with. A metallic asteroid, 500 meters or 1,640 feet in diameter, has a mass of about 200 million tons. Even if you use half of it for propulsion over a century, you're left with 100 million tons of construction material. That's enough to build pressurized habitats with walls 1 meter or 3 feet thick for square kilometers or square miles of livable surface. For comparison, the International Space Station weighs 420 tons and cost $150 billion. With the mass of a single asteroid, you could build the equivalent of thousands of space stations. Radiation protection is another huge advantage. In deep space, far from Earth's magnetic field, cosmic radiation is a silent killer. Astronauts in a normal spaceship are exposed to doses that drastically increase cancer risk. But on an asteroid, you literally have a mountain of rock between you and the radiation. You could carve your habitats 50, 100 meters, 160 to 330 feet below the surface and be more protected than you would be in an atomic bunker on Earth. And then there's the question of redundancy and safety. In a traditional spacecraft, a single catastrophic failure point can mean death for everyone. A meteor puncturing the hull, a life support system failure, a fire damaging critical systems. On an asteroid spaceship, you have so much space and mass that you can compartmentalize everything. You can have backup systems physically separated by kilometers of rock. If one section has problems, you seal the tunnels and move to another area while you repair the damage. Hey Curious Squad, before moving on, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. But perhaps the most revolutionary aspect is how this changes the economic equation of space colonization. The biggest cost in space exploration has always been launched from Earth. Every kilogram or 2.2 pounds you bring up costs a fortune. But if you transform asteroids into habitable spaceships, suddenly you don't need to launch massive habitats anymore. You only launch the initial equipment and the pioneers. Everything else, the habitat, the resources, even the fuel for propulsion, is already out there waiting for you. This opens scenarios that were previously pure fantasy. Instead of Mars missions with crews of 4 to 6 people in claustrophobic capsules, you could have migrations of hundreds of people on asteroid cities traveling comfortably through the solar system. Entire families could participate, with children being born and growing up during the journey. No more lone heroes risking their lives, but communities moving toward new frontiers. And think about it. Once you've perfected the technology to motorize an asteroid, you can replicate it. Every captured and converted asteroid becomes not just a resource, but a capability multiplier. You can use one asteroid's resources to build the equipment needed to capture and convert another. It's exponential growth. In a century, you could have dozens, maybe hundreds of these asteroid spaceships traveling through the solar system, each with its own community, its own economy, its own culture. The solar system suddenly doesn't seem so empty and hostile anymore. It becomes an archipelago of small mobile worlds, each self-sufficient but connected to others through communication and trade. An asteroid specialized in water extraction could resupply others passing nearby. One rich in precious metals could trade with one that has developed advanced manufacturing technologies. It's the beginning of a true interplanetary economy. Of course, there are significant technical challenges. How do you attach engines to an asteroid that might be little more than a pile of gravel held together by gravity? How do you manage the asteroid's rotation, which could interfere with navigation? How do you maintain structural cohesion when you're essentially shooting pieces of the asteroid into space for propulsion? These are real problems, but not insurmountable. Engineers are already working on solutions, from consolidating the surface with binding agents to using containment nets made of ultra-resistant materials. A particularly elegant approach involves using what they call a mass driver, essentially an electromagnetic cannon that shoots small projectiles of asteroid material at extremely high speed. Every projectile fired in one direction pushes the asteroid in the opposite direction. It's energy inefficient, but when you have millions of tons of free ammunition, efficiency becomes secondary to simplicity and reliability of the system. And let's not forget that all this isn't abstract theory. Companies like Made in Space are already developing technologies for manufacturing in space environments. The 3D printer on the International Space Station has already demonstrated that you can build tools and components in space. The next step is using materials not brought from Earth but extracted on site. And this is exactly what missions like the one to asteroid Psyche are exploring. How to interact with these celestial bodies, how to analyze their composition, how to eventually exploit their resources. But beyond the technology, there is a broader vision here. For the first time in human history, we're seriously considering not being bound to a single planet anymore. Not as temporary space visitors, but as permanent inhabitants of the solar system that becomes our extended home. Motorized asteroids aren't just a means of transport or a source of resources. They're the seeds of a truly interplanetary civilization. Imagine 50 years from now, the first inhabited asteroid has successfully completed a journey from the asteroid belt to Earth orbit. On board, 500 people have lived, worked, some were born, others died during the 5-year journey. They arrived not as space castaways, but as a thriving community, with their greenhouses producing fresh food, their factories producing goods, their culture that evolved during the journey. And while they orbit near Earth, they trade their resources, tons of platinum, purified water, electronic components manufactured in microgravity, in exchange for Earth technologies and luxury goods. The success of this first mission opens the floodgates. Suddenly, every nation, every major corporation wants its asteroid. It's no longer a space race, it's an asteroid race, but not to conquer and abandon them, to transform them into new lands, new opportunities, new beginnings. The cost? A fraction of what it would cost to build equivalent space habitats. The risk? Distributed across entire communities instead of a few heroic astronauts. And the most beautiful thing is we don't have to wait for miraculous technologies. Ion engines? We have them. Microgravity excavation techniques? We're developing them. Closed life support systems? We've been testing them for decades. What's missing is just the will to make the leap, to stop thinking of asteroids as rocks to visit and start seeing them as worlds to inhabit. This is the real revolution. We're not just adding engines to asteroids, we're redefining what it means to be a spacefaring species. No longer confined to fragile bubbles of metal and plastic, but inhabitants of real worlds, even if small, even if mobile. It's a paradigm shift that transforms the hostile void of space into a navigable ocean, dotted with asteroid islands that can become ports, cities, nations. The concept is already influencing how we think about space missions. Instead of seeing each mission as an isolated event with astronauts departing and returning, we're starting to imagine continuous flows of migration. A motorized asteroid leaving from the main belt might take 5 years to reach Earth orbit, but during that journey it could already start processing its materials, building infrastructure, even producing smaller daughter asteroids that break off like seeds for future missions. It's an organic approach to space colonization where each mission builds on previous ones instead of starting from scratch every time. Let's also consider the energy aspect. A 500-meter or 1,640-foot diameter asteroid moving at orbital velocity has monstrous kinetic energy. If you learn to control and direct this energy, you essentially have a giant gravitational battery. You can use close planetary passes to accelerate or decelerate, stealing or giving energy to the planet itself. It's like surfing the gravitational waves of the solar system, using the dance of planets to move where you want with minimal fuel expenditure. Calculations show that with proper trajectory planning, you could travel from the asteroid belt to Jupiter and back using less propellant than it would take to launch a geostationary satellite from Earth. Daily life on these mobile asteroids would be extraordinarily different from anything we've known. Imagine waking up in a room carved from rock with walls that have been smoothed and covered with polymers extracted from the asteroid's own carbonaceous compounds. You exit onto the main corridor, a tunnel 20 meters or 65 feet wide and 10 meters or 33 feet high, lit by LED strips simulating Earth's day-night cycle. You walk. Yes, walk, because this section of the asteroid rotates to create artificial gravity toward the central greenhouse, a stadium-sized cavern where fruit trees grow under artificial lights. The air smells of earth and green, produced by tons of soil created by composting asteroidal regolith with organic material from recycled waste. You have breakfast in a cafeteria overlooking an artificial lake, actually an emergency water reserve, but beautified with fish and aquatic plants for community morale. Then you head to your workplace, maybe in the Propulsion Control Center where you monitor the ion engine slowly but constantly accelerating your space mountain towards Mars. Or maybe you work in the mines, where remote-controlled robots dig new tunnels and extract precious minerals. Or in the manufacturing area, where building-sized 3D printers transform asteroid dust into components for expanding the habitat. In the evening, you might relax in the Central Park, an open space of several hectares or acres lit by an artificial sun, where children play on real grass while parents chat on benches made of asteroidal iron. There's even a small amphitheater where the local theater company puts on shows, because even in deep space, art and culture are essential for the human soul. And when you look up, Instead of sky, you see the cavern's rocky ceiling, but on large screens, real-time images of the stars outside are projected, so you never forget you're traveling through the cosmos. But it's not just quality of life. It's also economic efficiency at levels that would make any terrestrial business plan pale. Take water, for example. On Earth, we take it for granted, but bringing it to space costs about $10,000 per liter or $38,000 per gallon. An average carbonaceous asteroid contains enough water to fill several lakes. At space market prices, we're talking trillions of dollars in value. But instead of having to transport this water, you already have it there. You extract it, purify it, use it, and when you're done using it, you recycle it. In a well-designed closed system, the same water can be reused for centuries. And then there's manufacturing in microgravity, a field that's just beginning to be explored. There are metal alloys, crystals, drugs that can only be produced in the absence of gravity. On Earth, you can create microgravity only for a few seconds in drop towers or for a few minutes in parabolic flights. On the International Space Station, you have continuous microgravity, but very limited space and astronomical costs. On a motorized asteroid, you have cubic kilometers or cubic miles of space in microgravity, all the time you want, and the raw materials right there. You could have factories producing materials impossible to create on Earth, invaluable for medical, electronic, structural applications. We're talking about a space industrial revolution, no longer dependent on Earth for every bolt and circuit, but capable of producing everything needed on site and more. And this surplus doesn't necessarily have to return to Earth. It can be sold to other space missions, other colonies, other asteroid spaceships. A true interplanetary economy is created, with supply chains extending across the solar system. Food security is another crucial aspect that's brilliantly solved. On a traditional spacecraft, every calorie counts. Food is rationized, freeze-dried, optimized for weight and volume. On a large enough asteroid, you can have real farms. Not just hydroponic greenhouses, but arable land created by mixing processed regolith with organic material. You can raise animals, chickens for eggs, rabbits for meat, even aquaculture for fish. The diet is no longer pills and energy bars, but real, fresh, varied food. And this makes an enormous difference for morale and mental health of those living in space for years. But let's also talk about expendability. A traditional spacecraft has fixed dimensions. Once built, that's it. If you want more space, you have to build another spacecraft. But an asteroid, you keep digging. Every year, every month, you can add new sections, new rooms, new common spaces. Your community can grow organically. You start with 50 people. After 10 years, you can host 500. After a century, there could be 5,000. It's space urban planning, planning cities that exist inside mobile mountains. And let's not underestimate the psychological impact. Homesickness. Astronauts' homesickness is a serious problem in long-duration missions. But on an asteroid transformed into a habitable world with green spaces, lakes, even simulations of atmospheric phenomena like artificial rain and greenhouses, the sense of alienation is much less. You're not in a metal box in the void. You're in a small world, raw and artificial as you want, but still a world with its own geography, its places, its identity. And then there's the aspect of sovereignty and governance. Who governs an inhabited asteroid? Is it the territory of the nation that captured it? Is it a new independent nation? The legal and political implications are enormous. We could see the birth of space city-states, asteroid republics with their own laws, their own culture, even their own currency based on the resources they extract and trade. It's the beginning of a new geopolitical era, or should we say astropolitical, where power is no longer measured only in terms of terrestrial territory, but in controlled asteroids and space resources. Defense is another interesting aspect. An asteroid is naturally well protected, not just from radiation as we said, but also from micrometeorite impacts and space debris. The asteroid's mass itself absorbs impacts that would perforate any spacecraft. And in the case of conflict, let's hope never, But we must be realistic. A motorized asteroid is both fortress and battering ram. Its mass makes it practically indestructible with conventional weapons, and its mobility makes it unpredictable. This isn't military fantasy. It's strategic thinking for a future where space resources will be as precious as oil is today. And as we look even further into the future, motorized asteroids could be our vessels for interstellar travel. Not with current technology, obviously, but when we've developed fusion or antimatter propulsion, an asteroid provides everything needed for a centuries-long journey to other stars. Mass for shielding, resources for survival, space for generations of travelers. Our great-grandchildren could depart on an asteroid and their great-grandchildren arrive at Proxima Centauri, having lived their entire lives on what for them is simply their world, which happens to be traveling among the stars. Meanwhile, in the solar system, the network of inhabited asteroids would grow. Some specialized in mining, others in manufacturing, still others as commercial hubs or research centers. Imagine an asteroid entirely dedicated to scientific research, with giant telescopes mounted on its surface, laboratories carved in the depths, scientists from all over the solar system coming to study. Or a university asteroid where students from Martian colonies, from Jupiter's moons, from Earth itself, come to study space engineering, astrobiology, or zero-gravity art. The culture that would develop on these mobile worlds would be unique. Languages that evolve in isolation for years during journeys, then remix when asteroids meet. Traditions tied to planetary passages, festivals when passing near Earth, ceremonies when crossing the orbit of Mars. Children born citizens not of an Earth nation but of an asteroid, with passports listing his birthplace, asteroid 624 Hector, in transit to Jupiter. It's science fiction becoming anthropology, sociology, real life. And so as we look at the night sky, those lights we see moving slowly among the stars might no longer be just satellites or space stations. They could be inhabited asteroids, small worlds in motion, carrying humanity toward a future that, until yesterday, seemed only a dream. A future where we don't colonize space by building outposts on alien worlds, but by transforming space itself into our home, one asteroid at a time. Okay guys, is there anything you don't understand about what we've told you? If so, let us know in the comments. And if you want to learn more about interstellar travel solutions, watch the video here.